Yesterday, I said that I'm going to explain the few logical inconsistencies I found while I was studying quantum physics. Now, I started studying quantum physics after realizing that the standard TDSE, that is Time Dependent Schrodinger Equation, it cannot explain the wave function collapse mechanism. And the biggest problem in quantum physics, known as the measurement problem. Now, for the explanation of the wave function collapse mechanism, we need several different other models like decoherence model and various other postulates like Copenhagen interpretation and the Born Rule approximation, etc. So, then I started analyzing the boundary conditions of those equations, which are basically used to study quantum physics. Now, I'm explaining everything regarding a quantum hardware architect perspective. And I'm simply not claiming that those equations are wrong, but I think they are kind of incomplete. Now, the logical inconsistencies I found while I was studying those boundary conditions. Now, the first point, the isolation illusion. Now, in the standard TDSE operational under a strict isolated quantum environment, it simply assumes that the boundary conditions where neither mass nor energy exchange is permissible with the peripheral environment. So here, the energy conservation is strictly locked within the system level. That means within the quantum system level. That's the first problem. Now, moving to the second part, that is the passive external parameter. Now, to explain unitary evolution of the wave function within the closed boundary system, the standard physics uses Hermitian Hamiltonian energy operator. Now, under this particular setup, the time is treated as an external linear parameter that drives the state's rotation. Okay. Now, the core problem here is that these closed boundary conditions are mathematically limited. They can provide brilliant approximations regarding the mathematics, but the problem is they're incapable of explaining how a wave function is collapsing without an external or manual intervention. So this is another problem. Problem number 3, the logical contradiction of the probe. Now, what is happening here? When we are trying to explain the wave function collapse, we must introduce a probe to extract the which path information of that quantum entity. Now, the moment the measurement probe is interacting with the qubit which is placed inside that quantum environment, we are fundamentally opening an active energy exchange channel. And this channel is basically coupled between the peripheral environment and the system. Okay. Now, the point number 4, the shift to global bookkeeping. Now, because the energy exchanging across the boundary, it means the energy exchange is occurring between the system and the peripheral environment. The system is no longer isolated. So, basically, it is an open system. Logically, we can no longer use the strict Hermitian Hamiltonian energy operator because the energy has already got introduced within the system. So, the energy is no longer conserved within the system ledger alone. Now, the tracking of energy conservation must become global. So, here the model, when we are trying to discuss the wave function collapse mechanism, the system has to be open and the energy conservation should be at global level. It means that I am saying the system as well as the peripheral environment, they are basically tracking the energy budget together. Now, moving to next point, that is continuous drainage of sudden magic. Okay. Now, if you are going to consider operating an open system, it requires transitioning from a Hermitian to a non-Hermitian energy operator. Under a non-Hermitian framework, the wave function evolution can no longer remain perfectly smooth and unitary. It is literally impossible. However, it doesn't undergo a magical instantaneous collapse like the Copenhagen interpretation literally explains that there is a sudden jump. It is also not going to happen here. Instead, the wave experiences a continuous, deterministic, and non unitary drainage of its phase coherence. So, when the energy is getting introduced, what is happening here? The system is becoming open. We cannot use the standard Hermitian Hamiltonian operator used in TDSE, Time Dependent Schrodinger Equation. Now we need to move from that boundary conditions to the open system, global energy conservation model, and non-Hermitian energy operator, as well as we need to consider that without the energy, it is not possible for us to explain the wave function collapse. So these are the few major foundational inconsistencies I found while I was studying quantum physics. Now, you might think, what's the problem here? The problem here is that the standard computing models, while we are discussing about the quantum computing and qubit functioning, the gate operations, now regarding that situation, the if you are going to consider the problem that the standard computing model treat time as the active, independent driving force behind the quantum state decay, viewing decoherence as a random temporal accident, rather I must say like random stochastic noise. This kind of literature we have already studied. So in a practical real world hardware scenario, time is nothing more than a passive temporal ledger which is used to organize the chronological order of events. It means basically time is doing what? It is maintaining the order of events. Okay. Now the actual evolution, degradation, and the ultimate collapse of the wave function are fundamentally driven by the energetic perturbations. Now I can explain further, but I think this is the first part, and I'm going to explain this the kind of problems I have been facing for years in a separate video. Thank you.